All right, welcome to this video on graphing linear inequalities, and specifically we're going to be taking a look today at individual variable inequalities, single variable inequalities, not two level inequalities, which means that when we graph them, we're going to be graphing them on a number line instead of a coordinate grid. So that's just a little bit of a preface into what we're going to be taking a look at today. All right, first of all, let's go a little bit of review and what is an inequality. I get that some of you may not have seen this in a little while, and so it's important that we go over what is an inequality as a little reminder. An inequality is an expression that is open-ended and has a wide range of answers. Think of a question like, what is the legal speed limit? Okay, or what is a legal speed you are allowed to drive on the highway? Are you allowed to drive only at 100 kilometers per hour because that is the number on the sign? No, you are allowed to drive at 100, 99, 98, 97, 96, and a whole bunch more values which you are allowed to drive at. It is a range of answers, and that is the same as an inequality where there is a range of answers which do work for that statement. And it's important we understand there's not a singular number or singular value that works, but a range of values that work. And it's often with a limit and then either below or a limit and above. This one here, we have something like x is greater than 4. It gives an expression that lets x be anything bigger than 4 to solve the problem. If x happens to be 7, it's going to work because that's bigger than 4. If it's 2, it doesn't work because 2 is not bigger than 4. So that gives us a range, and there's a whole bunch more answers that would work, but it's important to understand that that is where the answers are given. So just a little review on our symbols. We have this one right here. It is greater than. It means that the left side is bigger than the right-hand side. So what's on the left is going to be bigger than what's on the right. So it's important to know that, and that's why we call it greater than. On that same note, we have our less than symbol. So whatever's on the left is less than whatever's on the right. Okay, left, less than right. And then we have a couple of maybe new symbols to some of you, and we have this little line underneath our greater than symbol, and that represents greater than or equal to. So whatever is on the left could be greater than or equal to the number that is on the right. It gives us, again, a bit of a set standard where it could be something like, you have to be 13 or older to be a teenager, right? All right, so 13 does count. It could be equal to 13, but anything above would count as well. I mean, that's a bit of a bad example because it only goes up to 19, but that just gives you an example of something that may work. And then we also have the less than symbol as well, where whatever's on the left could be less than or equal to whatever's on the right. So like a speed limit of 100. Well, anything that is less than or equal to 100 does work in this case here and could be a value, okay? So it's not just anything less than 100. 100 works as well. Remember that the point always goes towards a smaller number. Many of you have heard the expression of, the alligator or Pac-Man, or something's hungry and so they're trying to eat it, whatever the case that you're going to use. Okay, whatever's bigger, it's going towards the smaller one, right? So that big end goes towards the bigger one goes towards the bigger one every single time. There's the one example there, alligator always eats the bigger number. So an expression can be graphed to show the range of values which satisfy it. And again, we use a graphing method to do that. So something like x is greater than 4. When we graph it out, we could do it on a coordinate plane, and I'll show you that in later lessons. But for this one here, we can just take a number line. This is the number line for x. Okay, we label it with x. It's very important that we have that x on there. And then we need to put some numbers on there so that we know where we are at. Well, because 4 is part of our expression, 4 should be on our numbers as well. So I'm going to put it right there, not in the center, but towards the left-hand side. Now, we're told that x has to be greater than 4. So what we're going to do is we're going to start off with a dot at 4. Now, that dot, okay, is open because it does not equal to 4, okay? But it has to be bigger than 4. So then we're going to draw in a line showing that range of values which might work. And that's going to be this line right here, this arrow that's going to point in the direction which is greater than 4. This graph shows us that we have a kind of a parameter of 4, which is our limit, okay? and it's everything above 4, but it doesn't actually include 4 because that's where we have that open dot. So I'll get you to try this one here. If you want to grab a piece of paper and give this one a shot, try it out. Just give a little bit of practice. We would normally do this on the boards, but just try it out. What would this look like as a graph? Very simply. You can gladly pause the video, and then we'll start back up when we think you have the answer. So what is this going to look like as an answer? Well, first of all, we're going to draw out our number line, and I have 6 on the number line there as well. Okay, I have it labeled with an A right beside the number line. Okay, so you'll notice that A there, that should be there, just telling us which variable are we using. Just like our coordinate plane, we use X and Y. In this case, I'm telling you that this is A that we're using here. Now, we're going to start with our dot, okay, right there at 6. And it's going to be everything above 6. And so we're going to draw in that arrow that goes above 6. All right, let's try B. What do you think B looks like? Give it a shot. Pause the video. Start back up when you're ready. Now, this case, we're going to still draw a number line. And this is our number line here. It involves B. And I have 7 on the number line because that's our value that's a part of the expression. So we're going to put our dot at 7. Yeah, just like we did with the other ones. Now 7 just happens to be on the right-hand side. Now, because B is less than 7, where do you think that arrow is going to go? Yeah, it's going down. Okay, so we have to show that it's going to be the numbers below 7. Make sure that your numbers, by the way, on your number line are always going in ascending order, smallest to biggest. Sorry, smallest to biggest. Okay, so like 4 to 8 is what I did here. You could go up by different values as well. I just like having at least the number on there like 7. And let's go up by the same values each time. All right, give this one a shot. This one has a little bit of a change in there. Okay, see if you can catch it. Okay, let's take a look. First of all, we have to draw a number line. And what has to be on a number line? Well, first of all, the 12 has to be there. And second of all, it has to be labeled with C. So 12 is on there, it's labeled with C. Now, let's draw our dot. What does our dot look like? Well, it's a circle, right? It's a filled in circle. Why do you think it was filled in? Did you catch that? Do you remember this from grade 9? Okay, that filled in circle means that it is equal to that number, and it's equal to 12. Okay, sure enough, it's equal to 12, right? Now, could it be bigger or smaller than 12? Well, C has to be bigger than or greater than 12. So we're going to now draw our arrow, which is still the same as before, but it's going to be above 12, or it's going to be the bigger ones than 12. What happens to a decimal? So let's draw D. Here's our line for D. Now, you can put decimals in. Some of you might have tried when you made this. Some of you might have just done numbers. But where's 5.4? Well, it's just a little bit above 5, right? And I draw a solid dot in there because it could be equal to. So it could include 5.4. Now, I'm okay with that kind of roughness of where it is. Gladly do that, as long as, again, you have equal spacing between your lines. All right, less than, so we're going down, and it's going to look a little bit like that. All right, doing okay so far? Yeah, I hope so. Okay, let's give another one a shot here. What about this one? E is greater than 3/4. Give it a try. Pause the video. All right, let's take a look. E is greater than 3/4. Well, that tells us that we have to have our dot at 3/4. Is it going to be an open or closed dot? I hope you said open. Yeah, it's going to be an open dot. So let's draw out our number line. A couple different ways that we could do this. I decided to go with just numbers. If you want to do fractions, you gladly could. You could do 0, 1/4, 1/2, 3/4, and 1. That totally works as well. In this case here, 3/4 is just a little bit below 1. And so I'm going to put my dot there, and we're going to be going up from there. All right, the other way, like I mentioned, you could draw out fractions as well. I decided to put 3/4 just a little ways in and then do a couple of mixed numbers, but that totally works as well. All right, f is less than or equal to negative 4.6. Oh, got negatives. Okay, be careful with it. Try it. Did you get it? Let's give it a shot. Okay, drawing the number line out. I'm going to put negative numbers in. Remember, negatives go in the opposite direction as positives. So I'm starting with a really big negative of -8. I'm going up to a small negative of -4. Negative 4.6 goes right there. It is a closed dot because it is also equal to, and remember we have the f on there as well, so it shows that our number line has to do with f. and we're drawing a line down. Okay, think we're kind of getting this? Yeah. All right, let's throw a little wrinkle in here. What about this one? What does that look like? Give it a try. Pause the video, give it a shot. All right, now that you're back here, when we plug this in here, we need to get G all by itself. So what that means is we have to simplify this one. So first thing that we're going to do is we need to add 2 to both sides. Okay, don't forget that. Don't forget to add 2 to both sides. This is stuff that you went through back in grade 10. Hopefully you can remember the kind of that process. You did it back in grade 9 as well. All right, so you add 2 and you're going to be left with this here. We aren't doing anything different to the inequality. Okay, it's still the same way. Now, got to get that G by itself. We got to get rid of the 3. Okay, next, to get rid of 3, what do? We divide. Yeah, divide both sides by 3. It's going to cancel to 3, and it's going to make the 9 into 3. And so we're going to get the G is greater than or equal to 3. All right, now that we have our G all by itself, we can plot our number line here. 3's got to be somewhere in there. It's greater than or equal to, meaning we're going to have a solid dot, and it's going to be going up. And these are the values that work for G. Okay, so make sure that we simplify down to a single variable and then build up from there. Let's try a bit of a tougher one. Give this one a try. Okay, pause the video until you're ready. All right, now that we're back here, let's try to solve it. So let's go through step by step. First step, yeah, I heard you, subtract 6. I didn't show the exact steps there, but we're going to subtract 6, right? So we subtract 6 from both sides, we're going to be left with 4. Next step, got to get rid of that negative 2, right? Okay, how do we do that? Divide. Now, the important thing is when we do this, and this is something to remember from years back when you did this in grade 9, is you have to do something to the inequality sign. When you divide by a negative number, you're going to swap the inequality sign around. So instead of having a less than symbol, you have a greater than symbol. And so h has to be greater than negative 2. When we plot it, it's going to look something like that. And that's what our graph is going to look like. Okay. So again, be careful. When you multiply or divide by a negative, you need to swap the sign. Okay. So in this case, it switched from a less than to a greater than symbol. All right, let's try this one here. Give it a shot. Pause the video. Try it out. All right. So let's solve it here. Our first step is we are going to add 6 to both sides. Okay, do that, and we're left with positive 3. Now again, when we're adding or subtracting, we don't do anything to the inequality sign. Next step, get rid of that denominator. Okay, to do that, we need to multiply everything by 2, and that's going to mean everything. So in this case, we multiply both sides by 2, and we're going to get that I is less than or equal to 6. Plot that on the line. We have a solid dot and an arrow going down. All right, let's do one more. Oh, sorry, 2 more. I forgot I was going to K. All right, let's solve this one. Okay, pause it, try to solve, and then we'll come back. All right, step 1. What's step 1? Subtract 16. Good. Okay, I have some of the steps on here again. So we're going to subtract 16 from both sides. Now, when we're done doing that, remember that the negative is still in front of the 3, and negative 4 and negative 16 gives us negative 20. Second step, divide by negative 3. When we divide by negative, what are we going to do? Yeah, we're going to swap that sign around. So we divide both sides by negative 3, and we're going to get that j is equal to 20 over 3, or greater than or equal to 20 over 3, or 6 2/3. Okay. Improper fraction, mixed fraction, doesn't matter to me. They're the same value. But please keep that as a fraction, because if you change that into 6.666, okay, or 667, that's actually inaccurate. Okay, we've rounded it. Keep it as a fraction, keeps it as straightforward and accurate as possible. All right. So again, just remember that little the fact that we're switching that over. There's our graph. Plot it. And done. All right. Here's our last one. What does this look like? K is not equal to 2. You might not have seen that before. Try it. Give it a shot. Pause and come back when you're ready. All right. What's it going to look like? Here's our number line. We have a 2 there. Now, if it's not equal to 2, does anybody remember what kind of circle we draw? Yeah, we draw an open circle right there. What values could it be? Anything else. Yeah. So in this case, we got to draw arrows on both sides, and it's going to look something like this. So k does not equal to 2. All right. Try some of these questions out. Give them a shot. If you have questions, feel free to send an email, and I'll try to answer as quickly as I can. Plot them, graph them, solve them. You can do it. I believe in you.